Okay, so let's take a little bit of a look at some of the CAD on Design Spark Mechanical, which is free software. But of course, we'll be making available the files in other formats, or indeed, if you're not into editing them, you can just go ahead and download the STLs and basically send them off to any 3D printing bureau and get them that way, or print them yourself, of course. So, but going for a little bit of how I made and assembled everything, I thought it might be sort of fun just to sort of go through some of the things that were a little bit unusual or a bit novel. So the first one is, in case you didn't know, the rotary encoders are basically a very, very accurate component that made everything work. And all these components here basically needed to make sure that that component was accurately modeled. And rather than having to do that myself with a pair of digital calipers, it turns out you can just download those from the RS website, which is actually terrific. I also did the same with Raspberry Pi, and that just made everything a lot easier and speeded everything up. But if I take a look at the model now, I think one of the most striking things when you actually flip the model over is you realise the base is actually all like this. And you might be thinking, well, you know, why have you sort of gone and made it all difficult that way? And essentially the thing is, I've obviously spent years doing things for injection molded plastic, and if I just reach for something that is very typical, you can see on this screwdriver here, you've got inserts where the screws go in, and you usually work in what's called a clamshell, which is two pieces coming together. And so this is very easy, or relatively speaking, because it's a symmetrical design and there's not lots of what's called undercuts, which makes it hard for things to pull away, and you have to have complicated tooling. So the thing with a 3D printer is you don't have to worry about draft and undercuts and all these sorts of things, which is why I sort of took it upon myself to make something like this, which basically you can't even see any of the screws or details on the outside. And so that was just a bit of a fun thing, and possibly, you know, I'm not putting it in this league at all, but I've always loved the sort of minimalism, like most industrial designers, of people like Dieter Rams. And so it's sort of just quite fun sometimes to just go full all out, no screws, no nothing. But of course there's still assembly lines on this, and these were quite tricky, because when you're building it you have to appreciate that this part was actually rotated so that this face was on the printer bed, whereas the printer bed was on the top, and that means that you've got the sort of cleanest face going, but it does mean you get these little strata lines that build up. But unless you go for something like a commercial SLA or SLS print, which is done with usually lasers or light, it's a completely different animal altogether. But anyway, as I said, back to the base, the nice thing is that all the screws basically are sort of pull the parts onto the base from the inside. And so the trick with building that out was making it so that obviously it's accessible to the screws, and I could have made it a lot more heavy, but I wanted it also to be visible by kids, or indeed anyone who was just maybe walking past a tray stand. I've always been someone who likes seeing inside models, and there was a phase in the 90s, I think, when there was a lot of clear injection molded plastic on things like telephones and dishwashers, and showing you how things worked. So I kind of wanted it to feel really approachable and accessible. But either way, when you look at the CAD, you can see that, you know, essentially we've got the imported Raspberry Pi, the rotary encoders, but pretty much everything else I tried to model, even down to the brass inserts and the screw heads in critical places, because it's a classic mistake that you design something and then you forget that this thing has to sort of poke in from the side and tighten up. And so it's really important to just sort of go through that mental exercise of looking at the alignment and thinking, can I make sense of all these things? I think another nice little trick is, again, would have been pretty much impossible in injection molding, is if you look at the yoke and the cradle, as I've called it, which are these bits. They're basically they have hollow cavities, and so they print in one part. And you can appreciate you'd usually have to make this out of two parts, because in the section it's basically got a box section that goes all the way around. And similarly, what's great is that you don't even need to use 3D printer support material. It just builds carefully and sort of arches in and still allows all the wiring to go through. So that was definitely a really nice, cool bit of that that I was really pleased about. But it took quite a bit to actually perfect that. And so I think I've got a spare one here. And you can see this is where the wires come in through here. And essentially they snake through here and pop out this little bit here, and you can even see it's sort of been sloped to sort of facilitate them being pushed through. And yeah, that was kind of nice that this part is just made in one, and it's just, you know, would have been quite complicated if you had to do it a different way. So I actually like the fact that this whole product in some ways is very much a sort of testament to the advantages of 3D printing. So getting back to it again, I've tried to make it also, so if you remember this grill on the back here, again, it's sort of a little bit of a throwback to the first project I did with Raspberry Pi, where I did a case made out of cocktail sticks that used the diagonal shape of some corrugated cardboard to give it a particular aesthetic. So that's a little tip of the hat there for my first project with Pete Wood there. But I also thought it was nice to sort of make a design feature out of that intersection around the central cradle for the globe. And I think that comes away as a piece quite simply. And it's also, if you wanted to sort of be a bit different, it allows you to modify it, and you could print that in a different colour. And so it'd be a nice sort of visual language to sort of make the Raspberry Pi unit pop a little bit. I guess one of the other considerations I had when doing this was also the resolution of the 3D printing. And so one of the benefits of buying all these different nozzles, let's see if I can take this off, is I've got all these different 3D printing heads, and it's probably quite hard to see with this, but essentially the big one is 1mm diameter. And I found that you can actually make most of the model on that and get away with it. But the things like the rotary encoder components, those really you want to go down to 0.6. It's probably, you don't really want to go too much bigger than that, as it just gives it that sort of nice accuracy when you're sort of using components against each other essentially. So a lot of that is really the benefit of how the CAD was put together, and allowed me to sort of design that quite quickly and efficiently. And then all the other things like the sort of bushings and the couplings, those things I bought online, and I basically realised that it was very, very tight clearance between the brass coupling and the back of the LCD display screen. And so I realised that I needed to really maximise every millimetre behind there. As you can appreciate that when you actually look at it, this whole front panel there's really very little room to move there. I mean, I haven't gone to the usual nightmarish accuracy of Dyson, or dare I say Apple, trying to squeeze everything in, but I also feel taking pity on the person assembling it. That it's nice to have it, you know, relatively intuitive to take apart, I hope. So yeah, that's a quick walkthrough on some of the CAD. I think it's one of those things which, this is a great project if you haven't done anything like this before, because it shows you not just the relationship with off-the-shelf components, how to integrate your own ones, but also then to consider the difference between design for manufacture and assembly on a professional level, but actually how to get the best out of a 3D printing environment and interface as well. So I think it's sort of a good hybrid and a good all-rounder. And so, yeah, I hope it's a bit of fun, and thanks a lot. Bye.